So in the next section of the prerequisite chapter, we're going to be looking at section 5, which is all on factoring. So I think we're all familiar with factoring. I'm sure by now, having gone through Algebra 1, Geometry, and Algebra 2, you've done quite enough factoring to make you happy. But what we want to make sure we focus on here is to make sure something is completely factored. So, meaning it's completely factored means that there's no more possible factoring you can do. So each factor is either prime or irreducible. Except for a monomial. Monomial means it's only one term, and so you might, like one term, if it has a coefficient of 10, it's not going to be prime. But it's irreducible in that, because it's a monomial, there's nothing else we can do with it. Now, important here, what type of factoring should you always attempt first? I'll always refer to it as GCF, greatest common factor. So that means you're looking for what do all the terms have in common. So if we look at these first examples with greatest common factor, I'm just looking for what the terms have in common. So I have 3 terms here. It's a trinomial. What they have in common is that their coefficients are all multiples of 3. So I can factor out a 3. Notice that variable-wise, they don't have anything in common because your 15 is a constant and it doesn't have a variable with it. So we can only take out a 3. So I'm going to divide each term by 3. So we get 2x squared minus 3x plus 5. And since 2, 3, and 5 are prime, they don't have any other factors in common. If we look at the next example, first I'm going to look at, here's my terms, 3 terms, trinomial again. First we're going to look at the constants. What do the constants have in common? So those all have a factor of 4 in common. And then we're going to look at the variables. So we're going to look at the a first. So they all have an a squared in common. And then we're going to look at the b. So the greatest thing they have in common is a b to the 5th. So now I'm going to, not equals, now I'm going to divide through by 4, a squared, b to the 5th. So 12 divided by 4 is 3. A to the 4th divided by a squared. Remember, we're subtracting exponents because we're dividing. So we get a to the 2nd, b to the 8th divided by b to the 5th. Again, subtract your exponents, you get b to the 3rd. 20 divided by 4 is 5. A to the 3rd divided by a squared is a. B to the 7th divided by b to the 5th is b squared. Again, subtracting your exponents when you divide. 28 divided by 4 is 7. A squared divided by a squared is 1. B to the 5th divided by b to the 5th is 1. So that would be my factored form. Now, looking at those special polynomials that we looked at in the last set of notes, we're going to try to work backwards. So if you remember, the difference of 2 squares was created by the sum and difference when we were multiplying, meaning when we took x plus y times x minus y, it created x squared minus y squared. So you have to have the difference of 2 perfect squares in order to use this. We're going to work ourselves backwards. So notice that we ended up with the square root of each term. So we want to take the square root of each of these terms and then sum and find the difference between those. So the square root of x squared is x, and the square root of 9 is 3. And then we're going to do the sum of x and 3 and the difference of x and 3. And that makes it factored form. X to the 4th and 81 are both perfect squares. So the square root of x to the 4th is x squared, and the square root of 81 is 9. So we're going to take the sum and the difference. Now notice x squared and 9 are also perfect squares. We can only factor further though the one for the difference. So the square root of x squared is x, the square root of 9 is 3, so we're going to do sum and difference. And that is completely factored. If you had stopped the step before, you did factor it, but you did not completely factor it. Now with trinomials, there's really a couple different methods you can use. One I call the sum and product. So sum and product says that this only works whenever your coefficient on your first term is 1. So we're going to try it with number 1. So we're looking for factors of 9. 9 is our product that add to 6. So if I think of factors of 9, I've got 1 and 9 and 3 and 3. And the only factor that adds to 6, my 3 and 3. So I'm going to write this as x plus 3 times x plus 3, which now shows me that this actually we could have used a shortcut on for x plus 3 quantity squared that we learned in the last set of notes, which was the square of a binomial. So in that case it gave us x plus y squared is equal to x squared plus 2 times x times y plus y squared. So what you have to realize if you want to use that shortcut, which sometimes it doesn't pop out at you, is that your first term and your last term have to be perfect squares. In this case they were. The x squared is a perfect square and the 9 is a perfect square. And your middle term has to be 2 times x times 3. So 6x. If that's correct, then you could have just worked yourself backwards to the x plus y quantity squared. You also can use sum and product as I did. Now for the next ones, in order to factor these, you usually, because this coefficient on your squared term is not 1, we usually use something called the rainbow method. So let me refresh you on the rainbow method. Rainbow method, here's our rainbow, connects the first term and the last term. We're going to multiply those and get 6x squared y squared. Now it works similar to sum and product rule that I just used. We're looking for factors of what we rainbowed to get that add still to this middle term. Alright, so factors of this that add to that middle term. So I can use -1 and -6 to add to -7. We're going to have the x squared and the y with each of these, so they multiply to the x squared y squared. So you're going to use that to replace your middle term. So I get 2x squared. I'm going to replace here with -1xy minus 6xy. Notice if I added that back together, I'd get my minus 7xy plus 3y squared. Now once you make that substitution, you're going to group these up and take out the greatest common factor. So I'm going to pair them up. In my first pairing here, what they have in common is just an x. So I'm going to take an x out and be left with 2x minus y. In the second grouping, you always take a negative out if you can. If your first part of your second grouping starts with a negative, you want to take that negative out. A -3 and a y is what they have in common. So I would have left 2x minus y. Now, if you do rainbow correctly, you should get the same thing in those sets of parentheses. So then I can factor off the parentheses, and what do I have left? An x for the first term and a -3y for the second. And there's my factored form. So let's try that again for a review of rainbow method. We will be using this quite a lot throughout the year. So I'm going to rainbow here. So 15 minus 8 times -8, -120, x squared. Now we're looking for factors of -120 that add to -2. So I would say -12 and 10x. So I'm going to replace that middle term with those. So 15x squared, keep the first term, we're replacing this middle term here. Minus 12x plus 10x minus 8. Now pair them and take out the GCF. So GCF in this first one is 3x. I'm left with 5x minus 4. GCF in my second pairing is a 2. I'm left with 5x minus 4. So we factor off the 5x minus 4, and we're left with 3x plus 2. And that's factored. So I'd like you to pause the video and try to do this next example using, rainbow method. So 12 times negative 8 is negative 96x squared. So factors of negative 96. 3 goes into it. 3 and 32. Oh, that one works if we make it negative 32 and positive 3. So we're going to rewrite in here 12x squared. Now do our substitution. Plus 3x minus 32x minus 8. I'm going to group them up here. I'm going to factor off the 3x and get 4x plus 1. And remember, if there's a starting with a negative here on your second grouping, take the negative off, and an 8 in this case, and we get 4x plus 1. So then we take off the 4x plus 1, and we have left 3x minus 8. Hopefully you found that rainbow method is starting to come back to you. I have to say, rainbow method to me was like an epiphany, because back when I was in school, I never learned rainbow method, and we used to just have to guess and check. Guess and check can take a very long time if your first term and your last term have a lot of factors. And so when I was tutoring here in State College, once I had started teaching, one of my students said, oh, my teacher said to use rainbow method. And I'm like, well, I don't know what rainbow method is, so why don't you have her do it and then do an example, and then we'll look at it next time. And I was so excited when I learned rainbow method. So let's look at 2 more sets of examples. The next one is for the sum or difference of two cubes. And so when we're doing these, there is a method that some teachers refer to as SOP SMILE. Okay, and so I'm going to let you know what exactly that is referring to. All right, when we factor the difference of 2 cubes for the sum of 2 cubes, so here's the sum of 2 cubes. Okay, we're always going to take the cube root of the first term and the last term and keep the same sign. So that's what this S stands for, same. Okay, then in our next expression, the O stands for opposite and the P stands for positive. I'm writing too near to the top, it doesn't like to read my pen. So opposite sign, so since I was doing sum in the first quantity, we're going to do the opposite sign, and then we're going to do positive. So anytime you factor sum or difference of 2 cubes when you have a binomial, it's going to factor into a binomial times a trinomial. So what we get here, okay, is once we have a plus b, so this is our same sign, you're going to take the cube root of each. Then to get your next set of terms, that's where the SMILE comes in. So if we do the SMILE, we underline this first one. That reminds us, then when we do this, actually, I'm showing you that a little bit incorrectly. We do it from what we start with here. This, underlining this, means a squared. And when we go like this for our SMILE part, that gives us our middle term is a times b, and then we make our ending SMILE says b squared. Now if we were doing the difference of perfect cubes, okay, we're going to keep that same sign. We take the cube root of each, and then we do opposite, positive. okay, because we started with subtraction, and we get addition for opposite, and then positive all the time for that last one. And then we start our smile, we again get a squared, and ab, then b squared. So let's do it on an example here. So first thing I'm going to do is underneath these I'm going to write what the cube root is. So the cube root of x cubed is x, and the cube root of 125 is 5. So we're going to start out, this is sum, so I'm going to do x plus 5, we do same sign, and we do opposite sign, positive. Now I'm going to do my smile. So I underline this, tells me that I square it. This tells me I multiply those two, and this says I square again. And that's your factored form. We look at this next one. Again, we're going to take the cube root. So the cube root of 8 is 2, and the cube root of x cubed is x, and the cube root of 27 is 3. Now this is the difference. So I'm going to take cube root minus the cube root, and we're going to do opposite sign, positive. So here comes my smile. Make sure when you square 2x, you square the 2 and the x. Multiply these two together, gets us 6x. And then we're doing this, and we do square of 3, you get 9. And that's your factored form. Now the last thing is if you have a polynomial with 4 terms. And the only way you can factor a polynomial with 4 terms is pairing and taking out the GCF, and then seeing if it works like the rainbow method. So I'm going to pair this first set. I'm going to take out an x squared and get x plus 4. And in the second pairing, I'm going to take out a 3 and get x plus 4. And then since my parentheses are the same, I can factor out the parentheses and be left with x squared plus 3. So there's factored form. The next set, again, pair, take out the GCF. So I'm going to take out an x squared and be left with x plus 5. I'm going to take out a negative 2 and be left with x plus 5. Factor out the parenthesis and see what we have left. There's your factored form. So hopefully these brought back those things about factoring that may have slipped from your memory banks. We'll see when we're practicing in class tomorrow how much you can remember.